Hey, what's up everybody? This is Titan with Titans of CNC. And today I'm going to show you how to program the TITAN-2M building block. One of the cool things that we did with the series was we solved a few problems. One of the problems was material is expensive, so we standardized material. In this series, we use 1x2 standard rectangle bar stock, and all 10 parts from the building blocks series can be made from the same material. We also took a list of 16 tools, and you can make all 10 parts from one standardized tool list. All right, so you guys ready to do it? All right, let's make it happen right now. So we're learning through repetition, so we're going to do a lot of the same things we did in TITAN-1M, but we're going to do it on the TITAN-2M. All right, so what is the first thing we have to do? All right, first thing we got to do is we have to come up here and go from model, come down to cam, so we're ready to program. Then we have to set everything up. All right, so we're going to come over here, we're going to hit setup, and boom, you got your material. So now that we have our material, we have to set X, Y, Z coordinates. And so I'm going to come over here. I'm going to hit mode, orientation. I'm going to hit Z and X. So Z, I just have to hit a line on the part. So I'll just hit this line right here. And boom, it's right up there on center. It's asking me for my X. And even though it's correct, I'm just going to hit this line, which represents X axis. Okay, so I'm going to hit this line, boom, and now I got everything dialed in. Okay, so one of the things that we see now that we have our X and Y and Z in the correct, pointing in the correct axis, is it's in the wrong place. So I want this to be up in the upper left corner. Okay, so how do I switch it? How do I get this guy over here? That's this box right here. So we come down here. I'm going to say model box point. I do everything off of the model because it's precision machining. Material can change on you, but the model will always be absolute. It will always be perfect. That edge will always be where it needs to be. Okay, make sense? All right, so as soon as I click that, you see all these white dots that actually pop up. Okay, so all I'm going to do is I'm going to click this guy right here. Bang, and it is perfectly in location. I can see the material coming around the outside so that I know it is perfectly on the model. Got it? Okay, so the next thing we're going to do is we're going to go up to stock and we're going to pick our stock. We know that our material is 1x2 standard rectangle, 6061 T6 aluminum. So we're going to come up here and we're going to actually select the material to make sure that the material on this model matches our raw stock perfectly. Okay, so I want to have full control. So Fusion gives you a lot of shortcuts, but in this particular case, for education, I'm going to teach you exactly how to put it on all sides. So add stock to all sides. Okay, so now you see the material. The material is perfect to the part. And then I'm just going to click this guy and I'm going to tab. I'm going to hit my tab key all the way down. So from our setup sheet, we know that our part is 5.1 long. That's how much the raw stock is cut to. Okay, so I'm going to add 0.05, 0.05, and down here instantly I can see 5.1, so that is correct. Now I see 1.95 in my Y. The material size is 2 inches. That means that if I put 25 on this side and 25 on this side, all together it will come out to 2 inches. So I'm going to tab 0.025, 0.025, and boom, you got your 2 inches. All right, now when you look at the material on top, I just want to do a minimum facing across the top. So let's face maybe 20 thousandths, all right? And that would leave 230 thousandths on the bottom since our part is 0.750. So 0.750 plus 230 plus 20 equals 1 inch. And right here, I'm going to put 0.230, and boom, you see it drop down here. Tab, 0.020 right there. I'm rounding to the nearest zero, so that looks like my stock is on there. Everything looks absolutely perfect. So I'm going to hit OK. Boom. Oh, we're ready to go. Okay, so the first thing that we're going to do is the same thing we did with the TITAN-1M project. We're going to face across the top with a big old 3-inch face mill. Use our Kennametal face mill. So I'm going to click 2D. I'm going to hit face. I'm going to come over here and I'm going to select my tool. I'm going to hit building blocks, and I'm going to hit this 3-inch right here. Say OK. And all the speeds and feeds just drop down. Okay. So those are just standard, kind of standardized default speeds and feeds. But what I want you to do is I want you to actually listen to me and actually do exactly what I say and follow along, and I will not lead you astray. Okay. And if your machine can't handle the RPMs that I'm going to push it, then just back it off, but also back off the same percentage, back off your feed rate. Okay. So on this one, because a lot of schools have machines that run 4,000 RPMs, I'm going to run this at 4,000 RPMs. It's going to be kind of like a standard. And then once I machine this part, I will actually increase all the speeds and feeds. And then we're going to show you how fast we can get it done with awesome tooling and all our speeds and feeds jacked up. All right, so at 4,000, we might do it at 10 minutes or 13 minutes, but when we go up to 12,000 RPMs and we're running at, 300-400 inches a minute, then all of a sudden our part time is down at like just a couple minutes, and then you're making money, and then you're valuable to your employer because you are making things happen. All right, so I'm going to say 4,000. I'm going to tab through. I'm going to say, on this one, I'm just going to go 30 inches a minute. Okay. Actually, I think I'm just going to go 20. So I'll go 20, just nice and slow. All right. Did I just say that, nice and slow? I just want you guys to learn. Okay. So 20. So the plunge rate, that's actually coming down outside of material. So I'm going to hit 100 inches per minute. I'm going to come over here. The software, Fusion 360, already knows basically the containment, what it's going to be surfacing. So I'm just going to say OK. I'm not going to put any limits or boundaries on it. And then we're going to go do our heights. So model top, model top, model top. So it's 0.4, 0.2 feed rate, 0.1. That's where it starts feeding. Okay. And then here is the top height, and that's model top 0. And then here's the bottom height, and it's model top 0 because we're facing the top. All right. I want to explain something. I've had some people ask me, well, how come you don't program off of the bottom? Well, how come you don't program off of, the raw material? And different programmers do different things. This is how I like to do it. The part is always perfect. Material has, can be gouged. The material can be, big one, at one time, and then small. It can vary, right? And so I want something that doesn't vary. If my material is, say 1.9 or 2.03, you know what I mean? Then I want to make sure that I don't have excess material on one particular side more than the other because my part is smaller than that material. Not sure if that made sense, but so basically I do it off of the model, and then whatever the material size is, I divide I subtract the model from the material, whatever's left, I divide it in half, and that's the amount that I move in to re-zero. Okay, so when it comes to why do I do Z0 off the top? Simple. When you are submerged into material, and we are teaching a student, or we're just looking at anybody, I want you to know that you're submerged and that if you make a wrong move, you can crash the machine. All right. If we're up here in the sky and we're like flying around, and hopefully there's no stops, you can just move all over the place and there's basically nothing up there. Right? So think of this like the ocean. Once you're up here and you're coming down close to the ocean's surface, like you're 500 feet up and you're coming closer to zero. Now we're submerging, bloop, 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 right? So now it's negative. We're going negative into something. So when somebody's looking at a program and you see Z-1, Z-2, Z-3, you know that you're in the danger zone. You know that you're cutting material or you're in a pocket and you'll have to raise up to move over, right? And if you're in a positive, you're up here. So it's just like one of those things that if you learn it like this, you'll make way less mistakes, in my opinion. It makes perfect sense, right? If my zero's down here and my program is long and I'm having to make some edits or make some changes, because in the real world, sometimes we have to make those changes. This is positive, that's positive, that's positive, that's positive, that's positive, right? So when you really think about it, if it's all positive, you can basically kind of lose yourself without having, all the right calculations and stuff. So that is the reason. All right, so let's get back to it. Z0, let's come over here. Everything, this is only 2 inches, your tool's 3 inches, so none of this actually matters. So I'm actually just gonna hit OK, and boom. All right, what did we see? It came down over here, it moved in, came across, and went up. All right, so I don't like that. So what are we gonna do? We need that center of the tool to actually move off at least 1.5, right? At least 1.5, so you can get this part, this tool out of here, so you're not touching. If like right here, where if it's stopped, then this edge would probably leave a line on this edge and this would be discolored. So as a programmer, I need to know on my finish pass, let's take it all the way off. So what I'm gonna do, I'm gonna come up here, I'm gonna right click, I'm gonna click edit, I'm gonna come up here, I'm gonna go right here, go right here, I'm gonna go right here, and look at what we see. Pass extension. So let's go pass extension. Let's do 1.6. I'm going to tab over. When I looked at it, there was this big old radius and a big old radius. I'm not coming into material. I'm actually dropping down outside of the material. So that's actually kind of a waste of time to me. So I'm actually going to come up here and I'm going to basically just get rid of this right there. Boom. All right. And then, oh, look at that. It looks beautiful. Look at that. Boom. Psst, boom. And you have your facing complete. All right. So the next thing that we're going to do is we're going to rough all the material away and we're going to use 3D adaptive. It is amazing. So let's go up to 3D adaptive. Boom. All right. Now let's go to our 1/2 inch tool. Okay, so we're gonna go to building blocks. We're gonna actually go get our 1/2 inch flat end mill. All right, grab that bad boy. It's already at 4,000, okay? And just because I wanna be nice and safe, I'm gonna like drop it down a little bit. So I'm gonna go 30, 30, 30, 30 plunge. I'm gonna do 100 because it's not plunging into material. All right, makes sense? So 4,000 RPMs, 30, 30, 30, 30. Then I'm gonna come up here. Adaptive also knows your containment right here. So we're just going to leave it alone and say none. You know, I could say, oh, keep the tool inside the box, keep the tool outside the box, you know, or on the line. And that's not what I want to do. I just want it to allow it to do what it needs to do because it knows exactly how much material is on the part. Got it? Okay. Rest machining is on. I'm going to leave it on because we had a tool face off 20 thousandths. And if you took this off, the 1/2 inch would come up here and try to finish the top also. And that's not what we want. All right. So let's go to our heights tab. So model top 420, model bottom. It's exactly what we want. But I actually want my tool to go a little deeper by 10 thousandths. Okay. So I'm going to, right here, I'm actually going to go negative 0.020. All right. Now watch and listen, because I did 20 to get 10. And that is because later on, I'm going to leave stock on here, and the stock I'm going to leave on here is 10. So it's going to bring this 20 up 10, which puts me right where I want to be at 750 plus 10, which is 760D. All right, I just want to just go a little bit over my full thickness. Got it? So now we come over here. Optimal load, I'm going to go nice and gentle. So I'm going to go 75. So I'm going to say minimum cutting radius. That's fine. It's just roughing. Okay. So I'm going to come down here, climb cut, maximum, roughing, step down. That's like way down here, but that's okay because it knows that my Z is at 760. All right, so this doesn't matter. I'm just going to tab all the way down here, and this is what I'm talking about. So I'm going to leave 10 thousandths on the sides, right? On like this side, this side, this side, all the way around. And then in axial, we're going to leave 10 thousandths, which is going to leave it on here. And on the bottom, it's going to bring it up that 10 thousandths that I previously talked about. Got it? All right, moving on. So now I'm going to come over here. Everything looks really good. Stay down is at 70%. And that's just allowing it to move down here and just keep cutting and cutting and cutting, instead of like every time you take a cut, it raises up, moves over, down, up, over. Okay, so 70% is just saying, hey, most of the time, stay down if you can. All right, no engagement. That means when it's down moving, we want it to move faster than our feed rate because it's not in the cut. And so I'm just gonna put 100 because it's pretty safe. Okay. So now I'm going to do lead ends. That is fine. 50 and 50. We're plunging. Plunge clearance is fine. When the tool comes down, I actually want to see it. So since this is the back of my part, I'm going to take this line and I'm going to say, hey, bring your tool down over here and start machining over here. Okay, so what we do is we hit entry location. We actually hit this bad boy right there. And then I hit that guy right there. Let's see what we got. Ooh, looks beautiful, looks beautiful. All right, so look at this. So you can see the arrow coming down, boom, and then it starts feeding and it comes in and then it just starts like making it happen all the way around. Boom, boom, boom. That's our tool path. The tool path is really important because you got to make sure, like if you see a gouge or something happens, then you have a problem. You got to figure out what you didn't click or you did click that made it have that problem. This right here looks great. Okay, so now that we have the whole part roughed, we're going to take the same 1/2 inch tool and we're going to actually finish the part. Okay, let me say something. If we're at my shop and I'm trying to be competitive and I'm running 100 parts or 1,000 parts, I might run a roughing 1/2 inch tool, meaning a tool that roughs everything. And then let's say that's tool 2. Then I'll take another 1/2 inch, a duplicate tool, And I'll actually run it just to kiss the surface to make it beautiful, right? And why would I do that? I would do that because the roughing tool is going to wear out, which will affect your finish, right? Because once the roughing tool wears out, you just won't be able to like maintain a constant, beautiful finish. Okay, so I'd have a tool for roughing and a tool for finishing, and the tool for finishing would last way longer than the tool for roughing, okay, because we're beating it up, we're like running hard and fast. But for education purposes, and I don't want teachers and students and machinists to have to go buy 2 end mills and 2 holders, right? So we're just going to use the same holder. But as I go, I just want to kind of explain my thought process. All right, so now we're going to go to 2D contour. Boom. Okay. I'm going to come up here. I'm going to hit the tool. I'm going to actually say, hey, I'm going to use the same exact tool that I just used. All right. That 1/2 inch. I'm going to bring this over here. Okay. I got 4,000. Boom. 4,000. I'm going to come over here and I'm going to say, well, I'll say 25. Okay, so we'll finish at 25, see how that comes out. You know, it'll probably come out pretty good. All right, so we're going to say 25, 25, 25. I'm not really ramping, so it doesn't matter. And I'm going to say 100 right here. And that's going to be great. So then I'm going to come over here. There's nothing that is, nothing's actually touched off right now. Okay, so my contour that I want to do is this one right here, because I want to come all the way around the part. If I click up here, it doesn't reflect the whole part, right? So I'm going to click down here. I'm going to click this guy. And then I'm going to basically just come back over here. I'm going to check my heights, the top. I'm going to double check. Everything's at top. Everything's at top. It's even good to like look at it like this, right? And then I'm going to, ooh, look at this. This is way down here. So model top, model top, model top, model top. So what do I do here? Here, I can just say, you know what? I actually want to go all the way to the bottom. So I can say model bottom. And I know that my roughing tool went down 10 thousandths below that surface, right? So I went to 760. So I'm going to just drop down 0.005. Cool. So, and then it puts it right there. You know, realistically, I could actually come up here and I could just say model top, and I could actually just say negative 0.755. It'll do the same thing. I could actually come over here and I could just say selection, and I could just click that surface. And I could say negative 0.005, like the bottom. Basically does the same thing. So different people will have different ideas. What I believe is, you know what? If I always do model top, I'll be fast and efficient if I don't move things around. Sometimes I'll do it based on the complexity or that it's a 5-axis part. But since everything's model top, how about I just do model top? All right, so I just went through a series of different things, but it's more to just to show you there's more than one way to do things. Okay, so right here I'm going to go 755, and everything looks good. I'm going to come over here. I'm going to actually turn on cutter comp. So I'm going to say, for me, I'm going to put where right there, and I am absolutely good all the way through and through. Okay, so finish pass is 25. All I'm doing is a simple pass, so none of the other stuff really like comes into play. My tolerance is nice and tight. So I'm going to come over here. I'm going to drop down through here. It's just saying safe distance as far as if you actually come across it. So actually you can read it right there. Minimum distance between the tool and the part surfaces during the retract moves. All right, so that's just more like a safety thing. And so let's come down here. Boom. I'm going to change this to, let's say 45. It's just the angle. The angle that it comes in. Instead of coming in at a 90, it's going to come in at a 45. I like it. All right, and it says entry positions. There's none. I'm going to click this. I'm going to do the same thing because, you know, if I didn't click this, it'd probably do it like right here or right here, and it would create a line. So I'm going to put it where I already know there's a line, right? Because it made this like from here, kind of came in. There shouldn't be a line, but if I was going to put a line, like let's put it right there on the corner. All right, and try to make it beautiful. So I'm going to click it. Okay. Oh, looks good. Looks good. I love it. All right. So now we faced it. We roughed it. We just finished this. Now I got to finish on the inside here and the inside here. All right. When you look at the print shows you that this is 1 inch wide and you're using a 1/2 inch tool. So it's basically like edge to the edge, right? And because you're walking around this little corner, which is like 25 thousandths or something, 20 thousandths, when it walks around, it's going to leave this tiny little triangle right here. So what I'm going to do is I'm actually going to make 2 passes on this side, and then I'll come back and finish 1 time over here. And also, I'm going to do something that's actually going to shorten our programming time. So I'm going to come over here. I'm going to right click. I'm going to say duplicate. I'm going to duplicate this guy. I'm going to click this. I'm going to right click it again. I'm going to say edit. So basically I duplicated my entire cut right there with all my information in it. And now I'm editing it to make it perfect. I'm going to come over here. My tool's already selected. My feed rates are already selected. But now my chain is going to be different. So I'm going to click this guy right here. I'm going to zoom in. I'm going to click that guy. All right, but I actually want it to come around this side and over there. So I'm actually going to click it again. And I'm going to say this is going to be an open contour. I'm going to come down here. I'm going to click that guy. I'm going to double check this guy. It's already there. And I'm going to say, you know what? Boom, I like it. I'm going to look at the dark blue and the direction of this arrow, and my tool's coming this way. If this arrow was like inside the part over here, it would be a problem. So I'm going to look at it. Looks absolutely perfect. Okay, so I am good to go. So now I'm going to go over here. I'm going to do the same thing over here. So I'm going to say, boom. I'm going to click it. I'm going to say open contour. I'm going to zoom in, make sure I get it perfect. Boom. I'm going to double check over here that I got it. It's there. You can see it. See how it's blue and then it's blue, right? So it's good. So now I'm going to say, all right. So now I'm going to back off it. I'm going to look at both of them. And I'm like, yeah, I got to fly around. So, all right. Everything looks good. So I'm going to go over to my heights. All right. Now something's going to change. So it's model top, model top, model top, model top, model top, 0. Right? So everything's perfect. So clearance, that's just your clearance plane. Like the tools need to like come down, boom, to your clearance before they start engaging. Your retraction, your tools are coming up and then, you know, moving around and stuff. Your feed rate, your tool comes down and then it's like rapiding and then it starts its feed at 0.1 and your top height is the top 0 of your part, right? Where everything starts feeding down into. And down here, it's your bottom height. That is your Z depth in your cut. Okay, so it's your Z depth. Now, we got this guy right here. This is the depth, right? Because I'm cutting here. Okay, so because I'm cutting here, I'm going to look and I'm going to say, okay, what is the distance from here to here? Okay, but I can do that calculation. I can go look at my print or whatever, but since I know my print is perfect, I'm going to show you where actually using selection actually works. Okay, so I'm going to actually click this guy. It's pretty cool. I'm just going to hit selection. Like, I don't know what this Z is. I'm just going to click it, and that is going to be the established Z negative depth. Got it? So face, that's the face. You see the blue bar, boom, that's where it's at. There's no offset over here. I double check it, make sure. Then I'm gonna come over here, and guess what? We basically already did the finish passes, so our feed rates and everything are all pretty much perfect. There's only one thing that I'm gonna do is I'm gonna add a pass over here, right? So I'm gonna double it up here. So I'm gonna hit multiple, actually I'm gonna hit roughing passes, okay? It says maximum step over, but what it did was as soon as I did this, this popped up over here. See this? So I'm actually gonna say 250, half my cutter diameter. I know I barely need anything over here, but I'm gonna say do one step over at 250. All right, and everything else looks good. Of course, we're not leaving stock because we're finishing it, and all this looks good. I don't care about this right now because we know that it's gonna start out over here. All right, so I'm just say okay. Boom, looks good. So first thing it does is it actually comes over here. I'm trying to do the least amount of steps to just get this thing programmed perfect for you guys for education purposes. If this was a production part, I would actually make that in 2 moves. I would look at how quickly, I might even do a 3/4 inch end mill so I didn't even have to have 3 cuts, right? So if I knew it was a 1 inch, I might just use a 3/4 so I can just go boom and then come down, boom, 2 cuts and you finish it. Or I use a 1/2 inch, I just start here. I do the same contour, but I wouldn't roll it around here, and I would start here, do 1, and then I'd come around here, finish, finish. You know what I mean? Thinking about the shortest amount of travel and distance to make sure that you get your part times down so that you make money for your company. All right, so that looks great right there. Now watch. I'm gonna come back over here. I'm gonna right click it. I'm gonna duplicate it. I'm gonna click it. I'm gonna right click it. I'm gonna edit. Okay, and check it out. Everything is perfect. And we already did we already did our double. We're already at the right depth. So when I come over here, I'm gonna double check it, but I know I'm gonna be perfect. So boom. And these guys, this is all that needs to change now. So, okay, so we're gonna come over here and I'm gonna I'll do this one right here because it's easy. I'm gonna hit it one more time. I'm gonna hit open contour, hit that guy. I'm gonna double check this one. Yep, it's blue, we're good. I'm gonna okay it. You guys saw I was getting a little ahead of myself. All right, so now this one's good. My arrow's in the right direction. I'm gonna come over here. I'm gonna hit this guy, boom. Okay, I'm gonna come in, boom. Double check it. It looks good. All right. And you know what? I got a little issue over here. So see this guy right here? So it doesn't like something, okay? So what I'm gonna do is I'm actually gonna get rid of that guy right there. Okay. So I'm gonna come in here, I'm gonna right click it. So I basically hit delete, okay? So I didn't have to hit delete, but I actually did. So I'm just gonna go back in here. This is perfect. I'm gonna get back over here. I'm gonna actually get rid of this guy right here. If you ever think that you might have done something wrong or you might crash that machine, you need to just basically do it over. Don't take any chances. You can make one bad move and you're done. All right. So that was a small thing, but it's basically the same thing. Like, you know, instead of fumbling around, sometimes it's just better to just come back. So I'm going to hit this guy over here. I'm gonna hit this guy over here. I'm gonna be like, oh yeah, it's good. But again, something's wrong. Okay, so I'm gonna hit this guy. All right, that's what I did. I didn't hit it again. So I'm going to hit it again. Now I'm going to hit this guy. Got it? And then I'm going to come back over here. Let me hit that guy. That looks good. I'm going to OK it. Boom. All right, so I'm just double checking. I wonder if I actually made that mistake or if I was just showing you guys how to double check and fix things. You will never know. So anyway, I'm going to hit this guy. I'm going to hit this guy right here. Boom. I'm going to do this. I'm going to come in. Just like clockwork, I'm going to hit that guy. I like it. See, this is black. That's blue. I'm going to come over here. I'm going to double check it. It looks good. I'm going to OK it. All right. Looks good. I know this is going to be exactly the same. So all my Z's stay the same because it's the same as when I did the previous part. So now I come over here. Now something's going to change, right? So everything is exactly the same, but I got to turn this off. Boom. Which got rid of that one box over here. Okay. Now this guy is all going to stay exactly the same. And then I'm just going to say, oh, look at that. Look at that. It's smooth. All right. So, you know, when you look at how it came down over here, like I'm doing a radius and then it's a move in and then a radius, right? You can get rid of this radius. You know what I mean? So like that radius right there, I'm just showing you something. If I actually didn't want that and I just was like, you know, that's a complete waste of my time, I could come over here. And when you put your hand on here, it shows you right there. See vertical radius. See it? So, and then when you put your little cursor over here, it shows you that guy, your lead-in radius, right? And then this is your angle and stuff. So, you know, if I look at it, I'm like, you know what? That's a whole lot of extra movements and stuff. I could just get rid of this and what would happen? You know what I mean? So let's just do it. So I'll just get rid of that because I don't care if it leads in that way, right? And I'm just going to go, okay. It's going to redo it. And look, it just dropped down perfect. And it actually just swooped right in there. And it's beautiful. All right. So got to flip my part back around. So guess what? Now the part surface is all perfect. So we faced it, we roughed it, we finished it. I can actually do it. Faced, roughed, right? So then we finished the outside, we finished that part, and then we finished this part. Cool? All right, so what are we going to do next? We're going to chamfer this part, okay? So we're going to use a 3/8 chamfer because we have some 1/4-20 threads. And a 3/8 chamfer will actually create a bigger chamfer than a 1/4 inch. If I use the 1/4 inch chamfer, it would be too small, right? So on these threads, I want to take the chamfer about 25 thousandths larger in diameter. So if it's a 250 hole, we're going to make it 275, okay? And thus the 3/8 chamfer. So we're going to do a couple things now. So first, we're going to come up here. I'm going to come down. I'm going to say 2D chamfer. All right. I'm going to go pick my tool. I'm going to hit my building blocks. I'm going to drop down. I'm going to grab my 3/8 chamfer. Oh, keep it at 4,000. Beating at 20. I'm going to just click right in here. Man, it's so slow. Actually, I'm going to go 25. Okay. I'm going to say 25, 25, 25. It doesn't matter. And then on the plunge, I'm going to go 100. Okay. And now the contour, there's no contour selected. So, but what I'm going to do is I'm actually going to click up here. Okay. So we already drew the chamfer. So there's already a 10,000 chamfer there. So if I click the inside line, then I'm on the top surface, right? So I'm going to click that line. I'm going to click that line. I'm going to actually move my guy over. I'm going to click that line. Okay. And that looks all perfect. Sometimes, just double check it. Is it? Yep. Perfection. So I'm going to come up here. I'm going to go model top, model top, model top, model top, model top. It's all 0. Okay. So now watch. I'm going to come up. I got my wear on. My chamfer width. How big do I want my chamfer? I want it 0. I want it 0 because I already have a chamfer there. If I didn't put a chamfer, so like if I was drawing this and there's actually a part in my shop, I might not draw that chamfer. I'd leave the edge sharp and then I'd put 10,000s here and it would automatically create a chamfer. But since we already did it for education purposes, then I'm going to keep that at 0. I'm going to keep that at 50 and I think we look good. All right. So I'm going to come up here. And we're going to just take a look at some things. This says 0. I actually want something there. So I'm actually going to go say 0.075. I get 50, 100. It really doesn't matter because I'm only doing 10,000 chamfer. And on this guy, so when you come over here, you're like, oh, that's that. You move in. That's your vertical. I don't care. So I'm going to actually just tab right through. And I'm going to say, okay. All right, now I'm just going to look at it and I'm going to be like, okay, check this out. Boom, so it comes in, goes around, comes out, boom, comes down. Does the same thing over here. Does the same thing over here. So if I wanted it to start at a certain point, I could change my starting point like I did when I finished it, right? But this looks good. It's on the inside. It's not too visible. Okay. You guys like it? Part looks pretty good. All right. So next thing I'm going to do is I already have a chamfer. So I'm actually going to copy it. Okay. So I'm going to duplicate it. I already got my tool 14. I'm going to come over here. I'm going to actually edit it. And now, guess what happens? Check this out. This has a chamfer here, but this one doesn't, right? So this one has it, this one doesn't. So I only have one line. So all my speeds and feeds, basically everything's exactly the same. But I don't want to do these anymore, so I'm going to get rid of those. And I'm actually going to come down here, and I'm going to click this bad boy right there. Boom. Click this guy. Boom. Click this guy. I can click here, but what if there's a double line? I'm just going to flip it around because I like to be safe. I'm going to click this guy. Boom. It all looks perfect. The arrows are going in the right direction. All right. So everything looks really good. I'm going to come over here. I'm going to go to my heights. Top. 4, 2, 1, 0. Bottom height. Let's do the same thing. Let's come over here. Let's do a selection. Let's hit that bad boy right there. Looks good. I'm going to come over here. Now, guess what I'm going to do? I'm actually going to say 10. Nah, you know what? It calls out a nice big chamfer, and the chamfer is called out at 10 thousandths, typical, right? And it's showing it up around the top of the part. Okay, so it's showing it up around the top. See it? You can see it, right? And then it shows you these little radiuses here, but it shows it sharp here and on the bottom. But do I want to leave it sharp? I actually don't want to leave it sharp. So what I'm going to do is I'm going to actually do a smaller chamfer. I'm just going to do it at 5 thousandths. Okay, so I'm going to hit 0.005. All right, and then we're going to leave the 50. And okay, here's another little trick. So if 50 means my body is way big, right? And I'm gonna, over here on this clearance, it's gonna keep it off this side right here from hitting like boom, right? So I'm actually gonna go bigger on this. I'm gonna actually go like 0.125. And therefore I'm gonna come over here, I'm gonna say 0.20. And then when it does it, let's see how it looks. All right, so I'm gonna come through, everything looks good, everything looks good. I'm gonna say okay. All right, so basically you can see that it dropped way down, so it's using this part, right? So since it's using this part, when it actually drops in, so it comes down, boom, comes in, comes around, and basically keeps, as it comes in, it keeps it off this part. But you're using a bigger part of the tool, which also pulls this. If I was using the tip, you know what I mean? If I'm using the tip, then this entire thing is like stretched over here. Got it? So I think that that's like a good tool path. All right, everything looks good. Boom, 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 love it. Depth looks good, everything looks good. You can see this one is just right down there, but this one is actually much deeper because I used the top of the tool. Okay, so now what are we gonna do? We're actually going to chamfer and spot drill these guys, okay, by just coming straight down on them. So I'm gonna use the same tool. I'm gonna go to drill. I'm gonna come in, I'm gonna grab my same tool, tool 14, and I'm going to hit this guy. I'm going to use the same RPMs, but now I'll actually just go like 10. Again, it doesn't all matter because we're just plunging, but I'm just going to pop this guy in there. All right. So then we come down here. Click this guy, boom, goes in here, boom, 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 boom. Looks good, all right? So it optimized the order, selected the same diameter. I clicked it one time. It basically just started boom, 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 going all the way around. Now I'm gonna come up here. I'm gonna look at model top, 0.2, model top, model top. Model top is Z0. Okay, so now I'm going to drop it down. We're going to go down to a diameter of 275. Okay, so it's a 1/4 inch thread. We need to go 10% bigger. It's 275. So we divide 275 divided by 2 equals 137.5. There's a few ways to do it, but I'm just going to calculate it so you got it. So 0.1375. And I think it looks good. It already shows you where it's going. It looks good. I'm going to come over here. I'm going to say drilling, just straight in. There's no pecking. It's barely going in. And I'm going to say, you know what? That's actually good. Actually, you know what? This is a big tool dropping down into some metal. And because I don't know about everybody's machines, I'm actually going to peck it. Okay, so I'm actually going to come over here and I'm actually going to go boom, and then I'm just going to make some small pecks. I'm going to just say like 0.040. All right, and yeah, we're good. Makes sense? I'm going to click this guy, and there you go. Looks good. I like it. I like it. Okay. What's the next thing we have to do? The next thing that we're going to do is actually drill the hole for the 1/4 20. So the drill is actually a 0.228. It's for a roll tap or a borem tap. A roll tap is a tap that actually pushes material in, and then at the same time it retracts and basically forms a thread. Okay. And since, they basically, you program a cut tap and a roll tap exactly the same, but a cut tap, sometimes if you're pushing a chip, it'll actually create a chip that actually pushes down into the hole that can cause your taps to break if you're not careful. Or you can do another cut tap style that basically pulls the chip out, but a roll tap is good for aluminum. And I just want to make sure that you guys have success. Okay, so if you do a cut tap, just understand that your diameter size will change, because a cut tap is going to cut the ID of the thread perfectly, where a roll tap cuts it a little bit oversized because it knows it's going to pull the material back in. All right, makes sense? So this is a roll tap / form tap, depending on how you want to call it. Okay, so next thing we're going to do is we're going to drill with a 228. So I'm going to take this guy, I'm going to copy it by duplicating it. I'm going to grab this guy, I'm going to edit it, I'm going to come up here, and I'm going to actually go to my building blocks. I'm going to actually grab that drill right there. I'm going to say, okay. I'm going to, it's a drill. I got it at 4,016. It's going to work. It's going to actually work fine. Okay. So I'm going to say that that's okay. And even if you add like a cobalt drill, it'll still work fine. Okay. So I'm going to come up here. We copied it. We duplicated it. The holes are exactly the same. We're good. All right, so now we're going to come in here. Everything is exactly the same, but the depth is going to change. So now the depth is actually 375. Okay, so I don't know what your lead is, right? So different taps, different form taps are going to have a different lead. And that is like the lead is from like the tip to the first full diameter thread, right? So if that's like 100 thousandths or 150 thousandths, depending on how flat this, it's not going to be like a drill like this, right? So it's going to be kind of like rounded. So it's important to know what that is. And you can actually look at your tap on a comparator, and you can actually get that exact size so that you can make sure that you drill deep enough to actually allow your tap to go in to the full depth plus the lead plus this, right? Because your 375 is measured from the diameter of the tap thread. All right, hopefully that made sense. So since the thread is at 375 and my part is nice and thick at 750, I'm actually going to go nice and deep. Okay, so 375, 475, 575, 675. Let's just go 650. All right, it doesn't matter. So let's just go 650 on this one. Okay, and you can see, like, look at how nice and deep that is. Okay, so we're gonna go 650. I'm gonna actually pop back up here, and it's a deep drilling cycle. And when you read about a deep drilling, you'll see that it's just going to be breaking that chip. All right. So we're going to, by pecking. So we're basically going to come over here. I'm going to peck it. Again, it's education. Sometimes you can use like Kennametal drills where you basically drop down, 2 times, 3 times, 5 times D. There's coolant through drills. There's a lot of different applications. In this particular one, I'm going to be nice and safe because it's for educational purposes only. I might actually increase the drilling when we actually machine the part and do a second part at a high speed rate. All right, high feed rate. So I am going to take this. I'm going to say 0.075. It's a nice little peck. It's really like small, but it's safe. Okay, so I'm going to come down, boom, boom, boom. Everything looks good. I'm going to say, make it happen. And it looks like it happened. Okay. So drill. All right, let's come down here. And what am I going to do? I'm going to duplicate it. I'm going to edit it. I'm going to come over here and I'm actually now, it's going to be a little bit different. So I'm going to come back to building blocks. Now it's a tap. It's a quarter 20 tap. And it says right tap. So it says quarter 50 thousandths. It says 50 thousandths because if you take an inch and divide it by 20 threads, that would be 50 thousandths. That's why it says that. Okay, right hand tap, because if you have it in your right hand and you go clockwise, it'll be a right hand tap. All right, makes sense? So I'm going to click it. It defaults to 500. It's a decent sized tap. Not sure how much horsepower you have if you have like one of the really tiny machines, but you should handle it at 500. All right, shouldn't be a problem. If you got to like drop it down to 250, then just drop your feed rate at exactly half also. All right, so we're going to come over here and everything looks good. I'm going to come over here. Everything looks good because it's exactly the same. Now over here, I'm actually going to change this to 550. So I'm going to go negative 550, 375, 475. You know what? Just to be safe, let's do negative 0.5. All right. And that just keeps us safe. And then if you need to drop it just a hair, just make sure you start the tap from the very top in a new cycle so it follows that thread perfectly and that your tap actually orientates itself before dropping down. Okay, otherwise hand tap it if you think you're going to have a problem. Okay, so boom, 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 that looks good. Now over here I'm going to hit this guy. I'm actually going to come down to right hand tapping. I would, if I was you guys, I would actually go and read everything on that side. See, everything pops up. Just read it and check it out. You're not going to use everything, but it's good to know. Okay, so I'm going to hit this guy right here. Everything looks good. I'm going to say okay. Puts it in there. And guess what? Guess what? The part is finished. Like, it is finished. So let's actually simulate it. Let's see what it looks like. Okay, so I faced it, I roughed it, finished it, finished it, finished it. I did a chamfer, I did another chamfer, and then I pecked it. Basically, I centered the holes for the drill with the same chamfer, and then I came over here and I actually drilled it. And I came over here and I actually tapped it, making the part complete. All right, so I'm going to click over here and then we're going to right click it. We're going to come down, we're going to say simulate. Oh, look at that, look at that. Oh, it's so good, it's so good. It is a big boy, look at that, he's flying around. Yeah, so I'm gonna look at everything. Everything looks like really good. All right, so here's some cool stuff. You can actually turn on your stock. You can actually change the color, you know, just to check it out and stuff, right? So what do we like? What do we like? That's kind of cool, right? You can still see it. So I'm actually going to click this guy right here. It faces it, and look, I can see my part. Oh, look at that. I can flip it around, flip it around, flip it around. Boom. Oh, it looks good, looks good. I can flip it around, flip it around. Boom, 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 boom. Looks awesome. You see, like, it's just like, and that's when we said, okay, feed and then go faster, right? So it's 25, and then I think it was at 100 or something where it goes, boom, speeds up, boom. And in the real world, I would actually have that, you know, I don't even want to say because I know you guys are going to do it. But you guys will see. All right, so that looks good. You know what? It's looking good, so I'm going to, now let's just do it. So you come over here, you see all the paths. When I'm up here, I can actually see by clicking this guy right here, I can actually turn that off so you actually don't see your toolpaths. It's kind of cool. You know, so when you're looking at like a programmer, right? I always say like a shop is either good or bad depending on his or her programmer, right? Because a programmer, if he has a mind or she has a mind to actually make parts super fast, all right, we're kissing it, we're kissing it, we're kissing it, we're kissing it. If you have a mind to make things fast and efficient, then everything's going to run fast and efficient. But if you suck, then you won't. Huh. All right. So see that it made these passes right here. So it's coming in, making that pass, taking the 20,000s. Now it's coming back over, taking that guy. You can see it like rounded that edge right there. Boom. Taking that guy right there. I'm just moving it around so you can see it. So now it's deburring it, and you can see like, oh, it looks good. It looks good. It's kissing it. Look at that. Look at that. We already know it's going to go over here. Then it's going to go over here. Oh. All right, now it's going to drop down. Boom. 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 Come back over here. Oh, yeah. 5,000s. Pecked it. Pecked it. Pecked it. Getting ready for that 228 drill to come through. Looking good, looking good. All right, now the drill's coming in. Deep hole. Just pecking all the way down, pecking all the way down. So I'm actually going to speed it up just a hair. Boom, boom, boom. All right, now that tap came in. Boom. So basically it goes in clockwise and then it retracts counterclockwise. Clockwise, retracts. At the exact same speed. You can actually speed it up, but... And check that out, guys. Look at that. We actually finished programming the TITAN-2M building block. All right. So that's the cool thing. We just simulated it. We double checked everything and the part actually looks perfect. All right. So there's a couple things before we go ahead and post. One is, let's close this guy out. All right. Now look at our tools. See, so we had our first face mill. We had our 1/2 inch. So it's 1/2 inch, 1/2 inch, 1/2 inch, 1/2 inch, right? Because we roughed it in. We had 3 actual finish passes. Then we had our chamfer and our chamfer. Then we had our drilling, which is the same tool, 14. And then we came over here and we had our 228 drill. And then we came over here and we had our tap. And the order is out of order. Okay, so we're going to do something really easy. So we're going to come back over here. We're going to come up here to tool library. I'm going to click it. I'm going to actually just make sure that we're golden right here. Okay. And then I'm going to come over here. I'm going to click this guy. So renumber. I'm going to actually come here. First tool number. Boom. Increment by 1. I'm going to click that bad boy right there. I'm going to X out right here. We got tool 1, we got tool 2, tool 3, 4, and 5. 5 tools. The TITAN-2M building block. Woo, manufacturing, CNC machining, making it happen. Woo, I'm out.